Hi folks, welcome back. Today we're going to talk about inverse of a relation in chapter 1.4 of the Pre-Cal 40S course. Alright, so this covers outcome R5R6. There's going to be 2 videos for this section. Alright, so definition of a relation. So in mathematics, it's the connection between the x and y variables. One single x value may have multiple y values. All right? And now we're going to talk about what a function is. This is a particular relation where each element in the domain, so that's the x's, has one and only one unique element in the range for the y values. All right? So we're going to look at something called the vertical line test. So here is a diagram that I've drawn, a graph. This one is a relation, but it's not a function. And this one here is a relation, and it's also a function. So this passes the test to be a function. So let's look at what this vertical line test is. Basically, we're going to draw a line, or you could put your pencil down on the graph, and if it hits the graph at more than one spot, so it's hitting it here and it's also hitting it up here, it's hitting it here and it's also hitting it up here. So I cross the graph of that's on my paper twice. So once here and once here, once here, once here. It only has to do that once in order to lose its function status. Now this one here, if you put your pen on the graph and if you run it along anywhere, the graph is only ever coming in contact with the pen at one point at any given time. So therefore, this graph here has the function status. Okay, this one loses it because we have. So I'm going to erase this. For example, right here, you see this x value, the x value of -2. It can either have a y value of 1 or -1. So there's 2 y values. Now we're going to look at the inverse of a relation, and how it's found is it's found when the x and the y values are interchanged. So here's the mapping notation where we start with xy and then it becomes yx. So all we're doing is we're switching the x and the y in their places. So we're just switching the order there. Now we're given this here. This is a relation. These points make up the relation. And we are going to show the inverse of it. Now all we need to do is just rewrite the points so that we switch the x and the y. So that becomes 4 and -1. And sorry, my phone's going off. Okay, we'll ignore that. And this becomes 5, 3, and this is -2, 6. All right, so this is the inverse of our relation there. Now, we're not going to call it a function yet because we don't know whether it passes the status, whether it has the function status. Okay, everything is a relationship between the x and y values, but now we're looking for which specific ones are functions. So let's compare the two. So we've got the original and then we've got the inverse right here. So we're going to look at what the criteria is. All right, so here we're going to notice that there are no x values that repeat. So there's no way that we can have one x value with 2 different y values here because none of the x values even repeat. Now here, no x values repeat either. So therefore, it's impossible for the same x value to have 2 different y values. So this is a function. Both of them are functions. The original and the inverse are both functions. I should say both are functions. All right. Now let's look at the next example here where it says, given the relation below, sketch its inverse on the same graph. So what I've done here is I've taken this y equals x line and I've drawn a dotted line across it. That is what my reflection line is on when I'm looking at the graph of an inverse. So basically I can take it and I could fold it in half. And remember when you guys were in grade school and you'd do this artwork where you put paint blobs here and then you'd fold it in half and then then you'd get the dots would end up on the other side and you'd have a reflection. So this is the line of reflection here for us. I've taken these points and I've just written them out here so that we can write out what the inverse of the points are going to be. So this is going to be 1, negative 2. This is going to be 2, negative 1. This is going to be 2, 1, and 0, 2. All right. What I'm going to do is I'm going to plot these for my inverse. And over here, there's a little note here. It says, connect in the same order as the original function. Okay, so let's go ahead and plot the inverse points. So this one here is going to end up reflecting, and you can do this for the first little while, is just kind of see where approximately it's going to go if you do fold it. So this one here, this was negative 2, 1. It now becomes 1 and negative 2. This one here, it was negative 1 and 2. It now becomes 2 and negative 1. So it's going to go like this. I can connect them as I draw them. It might just be a little easier. So this one here, it was 1 and 2. It's going to become 2 and 1. So that's 2 and 1. So then that's going to connect with that one there. I should be using a ruler. And this one here is 2, 0, and it's going to become 0, 2. So that's going to end up going right there. So I'm just going to connect it like that. All right, so hopefully you could see in blue what I've drawn as the inverse of my relation. Now I want you to note the original graph is a function, so it passed the vertical line test. So if I did this on the graph that was given to me, it only crosses the pen at one point only. But what happens as I get to this point on the inverse? You notice here on the inverse it's going to cross it twice right around this area. So it's not going to be considered a function. It is not a function. The inverse here is not a function. Now it's possible to determine whether or not the inverse of a relation is a function without having to physically graph it. This can be done using the horizontal line test on the original function. So if I do this on the original function, then I can figure out that, okay, well, its inverse is not going to be a function. All right? So the inverse of a vertical line is a horizontal, and that's why that works. So the graphs of a relation and its inverse have symmetry over the y equals x line. So that's the diagonal line that I drew there, dotted. Let's look at the domain and range for these guys. So for the original function, the domain is between negative 2 and 2 on my x's, or we can write it like this. And the range of my original function is from 0 to 2, and I can write it like this. And now the inverse relation. So what's going to happen if you look at the inverse picture that we drew? Okay, so how have my x's changed? Well, now my x's only go from 0 to 2, and my y's go from negative 2 to 2. So if you look at the relationship between its original function, you're going to notice that it basically just swaps with the x's and y values. So just make sure you correctly put in the right letter in there, and you're good to go. You only need to state one of these, so that's an or there. Negative 2 all the way to 2 for the y's. So notice x's and y's just change places. All right. So now let's look at our inverse function. When we are finding our inverse function, this is the notation that we're using, okay? It's our f inverse, this little -1 exponent thing. It's not an exponent, it's a symbol signifying it's the inverse function. Kind of like, remember trig way back when we were figuring out the second function cos, it was the cos inverse, it had the same sign there, symbol. This here, this is 1 over f of x. It is not the same as the inverse, okay? This 1 over f of x is the reciprocal of f of x. It's a totally different thing. Now, in the graph of f of x, for this example, f of x contains this point. So that's on the original graph. Now we need to figure out a point that exists on the inverse. So basically all we're going to do is we're going to take this point and we're going to switch the x and the y. So now a point that exists on its inverse is simply the inverse of that point. So we're just switching the x and y. Real simple there. And now this question here, it says here, if f of x is equal to 3x minus 1, determine the equation that represents y equals the inverse. So we're looking for the inverse function. So the first step that we're going to do is we're going to rewrite this so that it says y equals 3x minus 1. All right, so we're just replacing the f of x with a y. And the second thing that we're going to do is we're going to switch the x's and y's with each other. So instead of a y here, I'm going to write x, and instead of a x here, I'm going to write a y. All right? And third, what I'm going to do is I'm going to solve this for y. So I'm going to add 1 on both sides. X plus 1 equals 3y. Then I'm going to divide both sides by 3, and then I end up getting y equals x plus 1 over 3. Now, the last step you have to make sure that you do, which is often forgotten, is to replace this y with f of x, because we were asked to find the inverse of f of x, not y. So we need to change it back to what it was originally called. So this is the inverse function here, and that is x plus 1 over 3. So this is the inverse equation of this right there. Okay? So here I should write, sorry, I missed that minus 1 there. Okay, so here's a couple of questions to go on with. I'm continuing this lesson with a couple of more examples, so stay tuned.